Good morning, good afternoon, and good evening to the audience from different parts of the world. Welcome to today's webinar session conducted by Deshapex. My name is Jaren Biju, associated with Deshapex as project coordinator. The agenda for today's webinar, we will start with a small introduction to Deshapex. Then we will move to the webinar topic CDE and its importance, which includes need for CDE, ISO 19650 framework of CDE, implementation strategies of CDE, and we will conclude by looking at the benefits of the CDE. Let me introduce you to Deshapex. Deshapex is a digital engineering organization working towards digital technology integration in the AEC industry to improve the life cycle of built assets. We provide complete digital solutions throughout the life cycle of the building or infrastructure, that is design, construction, operation and maintenance, and renovation stage. Our customer segments includes hotels and restaurants, corporate real estate, residential, airport, data centers, railways and metros, logistics and warehousing, factory buildings, top-rated retail business stores, and infrastructure. I would like to brief you about the digital solutions we are providing to our clients, which are three verticals of Deshapex. That is digital design management, digital project management, and digital asset management. Under the digital design management, we provide the solutions for clash detection and coordination, including architectural, structural, mechanical, electrical, plumbing, and firefighting modeling, and also BIM-based pre-construction services. At Deshapex, we provide our clients to translate the conventional 2D drawings into the 3D BIM models and perform these simulations before we even go to the construction site. The digital project management, we are providing to our clients to manage their construction projects digitally, where we provide a digital information delivery plan, technical due diligence, and setting up a digital lab. And the digital asset management, here we assist our clients to digitize their project documents in terms of the latest as-built 2D drawings into 3D BIM models, and we also digitize their existing physical building like the building after the handover stage or during the operation stage. We are partnered with Finnish company Granland. We have an integrated tool called a Grandland Manager, which is used to provide the solutions like BIM for facility management, in which we provide maintenance management, energy management, asset management, and also real estate portfolio management services using the BIM model. This is our young passionate team, and we have civil, mechanical, architecture, and electrical BIM engineers, which blends the expertise in domain, process, and tool, and provide the owner an unmatched performance. And this is our approach to deliver quality projects on time. This is the USP of Deshapex. I feel proud to say that we are the first company in the world and only company in India to have this kite mark from the British Standard Institute, which is a global standards for BIM, and it is for ISO 19650 Part 1 and 2. This is all about the Deshapex portfolio. Before going to today's session, we would like to know the professional background of the attendees. So please take the poll. Thank you for your response. Oh, the result shows that attendees are from multiple roles, and that talks a lot on how AEC industry takes digitalization forward. Now we will start with the topic for discussion in today's webinar, Common Data Environment, in short CDE and its importance. The world is in the process of digital transformation. The AEC industry is also changing from its traditions. The two major aspects in digitalizing the AEC industry are building information modeling, BIM, and our today's discussion topic, CDE. Before going to the webinar topic, we will glance through another area, building information modeling or BIM. BIM is the process of creating and managing the information related to an asset through the entire life cycle, starting from the planning, design, construction, and continues in the operation stage till it is demolished. The information delivery cycle seen on the screen is the workflow that graphically represents the information exchange throughout the project lifecycle. As you can see, the common data environment is the underlying layer that holds the overall project information tied to different stages of the project. What is a CDE? A CDE is a collaborative environment where all stakeholders on a project or asset work on and share information. The CDE is essential for the effective and efficient implementation of BIM processes and technologies. Have you ever thought of the information that is being generated and managed? The information that is being generated and that has to be managed with respect to a project start from the design brief report, 3D models, drawing sets, request for information, tender documents, contractual or legal documents, quotations, time schedules, cost estimation, QA/QC checklists, closure and handover documents, minutes of the meeting, progress reports, documents as per ISO 19650, operation manuals, and many more based on the project. The traditional method, these information that we saw in the previous slide are stored in a computer and transferred via mail or other methods when required as a manual process that can cause errors. All this information is siloed at multiple locations under the custody of multiple people that creates conflicts. Here comes the need for a common platform where every stakeholder can generate the information collaboratively by sharing the right information with the right people at the right time. This is the common data environment. A CDE is a technological solution to store, manage, and share the information. But the CDE solution becomes meaningful only when a proper CDE workflow is set up. A common data environment is a single solution or platform which has an organized workflow to store and manage all information regarding a project from its initiation stage and continues the entire life cycle of an asset. The organized workflow refers to the timely communication of quality information between the relevant stakeholders of the project. This workflow has to be defined properly in the CDE with the relevant access control. It also helps for structured information development, reviews, approvals, and authorizations of information created during the delivery phase of the project. The CDE solution is implemented through a shared server or a web portal. Autodesk Construction Cloud, Autodesk BIM 360, Google Drive, and Microsoft OneDrive are some of the examples. The CDE is set up by the appointing party or the third party who is a service provider appointed by the appointing party. I'm sure that you will be curious to know how it is going to help in project management. Now we will go to that part. CDE and project constraints. Even though Even though there are many aspects when it comes to project management, the main constraints of a project management are time, cost, scope, and quality. In the traditional method of project management, a lot of time is wasted by searching for the right file. A properly managed CDE saves the time of multiple stakeholders that are lost by searching the relevant file. Almost 5 to 15% of the time is spent on reading information, but up to 50% of this time is spent on looking for it. One stakeholder might be using the other stakeholders model for clash detection and coordination purposes. For example, the architecture and structure model is used by MEP consultants for modeling purposes. If they use a previous revision of architecture and structure file to generate the model, it will lead to rework which affects the time, cost, and quality of the project. Another important fact in project management is communication. The oral or the electronic communications happening is a manual procedure. The chance of occurrence of error is very high. For example, the client shared a set of drawings with a consultant to convert into 3D BIM models. The consultant started modeling it. Later, the client realizes that the drawings shared were of older revisions. If the same process was happening through a CDE solution, the consultant could have used the drawings that are in the shared folder, or the client can easily share the drawings in the published folder with the consultant. There is a loss of money and time due to rework. CDE and stakeholders. The first and foremost thing is that none of them has to think of where the files related to a project are stored. The relevant stakeholders can easily get to the respective project CDE and use the files that have access to them. The information in a CDE has controlled access and it is secured. All stakeholders don't have access to all information in a CDE. Only relevant stakeholders have access to the relevant information. So the information generated by a stakeholder is not inherited or used by other stakeholders unless they approve it for sharing. The ownership remains with the relevant stakeholders themselves, which means other stakeholders cannot make any changes on that particular information container. Second thing is that file naming convention helps the stakeholders to identify the right information container. The status code along with the file name helps the stakeholders to understand the purpose of the information being shared. This makes sure that the right information is being shared for the right purpose. Again, the version and revision number in the file name helps them to identify the latest set of information that is being shared. CDE and communication. According to the ISO 19650 framework for CDE, three levels of communication happens. Level 1, communication within the task team. The task team members are working collaboratively on the same information container to generate the required information as per the project requirements, and the information generated is reviewed within the task team by the lead. Level 2, communication within the delivery team. The second level of communication is between the task teams within a delivery team. One task team may use the information generated by the other task teams to complete their tasks or other use cases of BIM in the project perfectly. The information generated by each task team is reviewed by the lead appointed party. Level 3, communication within the project team. The third level of communication is between the lead appointed parties and the appointing party. Each of the lead appointed parties submit their deliverables to the appointing party for the final approval. All the above levels of communications happens through an automated process that avoids miscommunication and errors in the communication. So it is really important to have a properly managed CDE as per ISO 19650 for a systematic approach for information management in the newly digitizing world. Now we will move to the second topic of today's session, ISO 19650 framework of CDE. The slide shows the conceptual diagram of a CDE as per ISO 19650 and how the information flow is happening from the WIP state to the published state. All the information will be in any of these states. Let's go through them one by one and understand what information can contain in each of these states. Work in progress. In general, work in progress is the state where information generation happens by each task team. In every project, there are architects, MEP team, fire and public addressing system, etc. And each of the teams can be considered as a separate task team. Information containers at this stage are not visible or accessible to any other task teams. Enables collaboration of information between task teams or within a delivery team. The status code is S0. Once the information is developed, it is reviewed by the task team based on TIDP or MIDP, methods and procedures, acceptance criteria, and standards. If yes, the information container will be moved to the shared state. Shared state. A shared state is a place where the information from all task teams of the project comes in for collaboration and coordination after first level of quality check by the task team lead. The information containers at this state can be viewed by all other task teams but cannot be edited by them. This information container is used for coordination or for reviewing or stage approvals. Status codes S1 to S7 are used to identify the purpose of information containers. State may have the information containers that have been approved for sharing with the appointing party or client that is ready for their authorization. Once those information containers are approved or authorized by the appointing party, they will be in the published state. Published state. The published state holds the information authorized by the appointing party that can be used for the next phase of the project. If the model is approved by the appointing party, the same can be used for the execution or asset management. Archive state. The archive holds a journal of all information containers that have been shared and published during the information management process. It has an audit trail of information that is generated. This helps to track the development of information, changes that are made, when it was made, why they were made, and which version of the file has that particular information. The ISO 19650 gives a general CDE structure that can be followed in all projects. How it has to be subdivided depends on the nature of the type of project and its deliverables. A project can have an n number of documents and how to distinguish between them. We will discuss these things in the upcoming session. Now we are moving to the third topic of today's session, which is very important. Implementation strategies. The implementation of CDE happens stage-wise. First is to identify the right CDE. The CDE should match the user requirements and workflow of the organization. Second is the structure of the CDE. It is the speciality of the AEC industry that each project is unique. Similarly, the project CDE structure is also unique, even though the outer shell remains as per ISO 19650 as discussed in the previous section. The third stage is the file naming strategy. This is for the identification of each information container. The naming standard is followed based on the mutual agreement between the appointing party and appointed parties in the BEP. There are two more parameters that complete the naming standard: the status code or suitability code, revision and version codes. The status code helps to understand the purpose of the information container. The revision and version code helps to identify the latest updated information container. We will go through each of these stages in detail. Identification of right CDE. User-friendly. The CDE need not be always used by a technical person. It is also used by non-technical people as well. So CDE should be selected in such a way that it should be used by all relevant stakeholders by providing minimum training. Accessibility. In the present situation, especially after the pandemic, accessibility plays a major role. Every organization has a thought that anything can happen at any time. So the information should be accessible from anywhere in the world. This feature gives an advantage of accessing the data from the job site as well. Security. In the present world of cyber attacks, it is very important to have the proper data security because the CDE is the one and only place that is going to have all the crucial information related to a project. So it should be safe from unauthorized access, data breaches, or other calamities. Integration. Selection of any technology plays an important role in the organization level itself. Otherwise, it can lead to business problems. One of the use cases of CDE is to avoid working in silos. An extra care has to be taken to avoid this. So, the CDE that is being selected also should smoothly integrate with the current process and system of the organization. Standardization. The speciality of any project in the AEC industry is the uniqueness. So this uniqueness can be considered as one of the barriers in implementation of new technologies. This uniqueness effect can affect standardizing the workflow within a CDE. The workflow may vary from project to project based on the review mechanism, complexity, and size of the project. The CDE should fit in for any project with a minimal change from the defined standards. Structure of the project CDE. The basic structure of the CDE as per ISO 19650 was discussed above. How each of these folders has to be further subdivided is a confusion with many people. It can be done based on the types of information containers like 3D model, 2D drawings, reports, etc., or discipline wise like architecture, structure, HVAC, electrical, etc., or based on the consultants and contractors organization name. This will depend on the project, but make sure that none of the files are kept outside a folder. All the files should be within a folder. This can be considered as a best practice to manage CDE properly. There should be a folder for each file where it fits in, even if it contains only one file. Work in progress folder. This is the place where each of the consultants or contractors generates the information. It's better to give specific folders to either each appointment or discipline wise within the WIP folder. Each of these folders should have access control in such a way that it can be accessed and edited only by the team who is generating it. None of the other parties should not be able to access it for any purpose. Shared folder. The shared folder is the place where the parties upload the files with complete information generated based on the project requirements and deliverables for different purposes like coordination, review, etc. after the first review within the task team. This information may be used by other parties for any reference, coordination, review, etc. The shared folder can be further divided in different ways, discipline-wise, based on the appointed parties, based on the type of files, or based on the different stages of construction like conceptual stage, schematic stage, detailed design stage, construction stage, etc. The access control can be provided in such a way that all the information has to be accessed by all the other parties for any purpose, but it cannot be edited by any other parties. Published folder. The published folder contains only the information that is approved by the appointing party. This folder also can be further divided as shared folder based on the discipline, appointed parties, or based on the different stages of construction. The access to this folder is restricted only to the appointing party. No other parties have access to this. Archive folder. The archive folder is to store any files that are not required in the project anymore. Such files from the shared and published folder are moved here. How the folder has to be subdivided can be decided by the appointing party. The structure of the CDE may vary depending on the project. There can be further ways to define the folder structure. Next, we will move to the third part of the implementation strategy, file naming standard. The file naming convention is an important aspect when it comes to a CDE for easy identification of an information container. The file naming convention has to be included in the BIM execution plan, and it has to be mutually agreed between the appointing party and other appointed parties. There is an annexure attached to the ISO 19650 document specifying the file naming convention for the information containers as shown. The file name is separated by delimiters. Project, originator, volume or system, level or location, type, role and number. Now we will go one by one. Project. Each project has a unique project identifier like project name or project code that is defined at the starting of the project, and the same is followed throughout the project. The same project name or code can be followed here also, but the number of characters should be between 2 and 6. Originator. There will be multiple organizations related to architecture, MEP consultants, interior designers, landscape consultants, facade consultant, general contractor, MEP contractor, etc. in a single project. As the name originator indicates, it is to identify who is generating the information within that information container. The number of characters should be between 3 and 6. Volume or system. For large projects, the entire project will be divided into multiple blocks or zones. As a reference to that particular block or zone, volume is used. A list of codes with the number of characters limited to 2 digits can be made and followed if the organization is not following any other code similar to this. There are 2 additional codes that have to be added along with the zone or code. The code XX and ZZ. The code XX states that the particular information container is not applicable to any of the volumes or systems. The code ZZ states that the particular information container is applicable to all volumes or systems. Level or location. This identifier refers to the area at which the information container belongs to. It can be floor level or a particular location. The length of this identifier is restricted to 2 characters. There is a standard code that has to be followed as shown and can be expanded as per project requirements. The standard codes are shown in the table. Type. This identifier is to identify the type of information within the information container. There can be multiple information related to a project like 3D model, 2D drawings, project schedule, BOQ, cost estimation, reports, MOM, etc. This type identifier helps to segregate and identify between them. The code length is limited to 2 characters. There is a standard code list for this identifier as shown in the table. Next is role. This identifier refers to what an organization does in a project. There can be a single organization working on multiple domains of a project. The role identifier helps to identify the particular domain of the project the organization is working on. Number. This is a sequential number provided to each information container to distinguish between information containers when all the other identifiers remain the same. The character length can be between 4 and 6. Here is one more poll question for you. Do you see any essential fields in a project file name that is missing? Something to be added? Status code or suitability code? Revision and version? Not sure. Please mark your response. As the poll shows, it's not over. There are 2 more important parameters that have to be added along with the naming convention. The foremost thing is status code or suitability code, and the second one, revision and version, which also plays an important role in file naming convention. Now we shall go through these 2 parameters in detail. Suitability code or status code. The suitability code or status codes are to identify the purpose of the information container it should be used for. Certain information containers are used only to use the information, some other might be for coordination. Containers might be for review and approval. Usage of wrong information containers creates another wrong information container. The usage of right information containers for the right purpose helps in generating another right information container. This can be achieved by providing the appropriate suitability codes to the information container. The suitability code S0 defined as the initial status used with all information containers in the work in progress state. Any model or document or drawing that is in this state is provided with S0. The suitability code from S1 to S7 is used for the information containers in the shared state of the CDE. This suitability code given for the information containers is in shared state plays a vital role as these information containers are used by other parties. So the information containers here should be provided with appropriate suitability codes while uploading or transferring from WIP to shared state. Similarly, the party who is using the information from the shared state should check suitability codes to understand whether it is the appropriate information container that matches their requirement. As mentioned in the table, the information containers with the status S1 can be used for coordination with other parties. For example, consider the architecture model is provided with the status code S1 in the shared state. This information container can be used by the HVAC team for coordination. Similarly, if the status is S2, that information container can be used only to take information from that model. It should not be used for coordination purposes. Similarly, if the status code is S3, that information container is submitted for review. If this container is used for coordination, it can result in generation of a wrong design by the HVAC team. The information container with status code S4 shows that it is waiting for the approval from the appointing party. The status codes with the status codes used in published state A1 to AN refers to the approved information container by the appointing party. Similarly, the status code from B1 to BN refers to the information container that is approved with the comments. This status code changes once the comments are updated. The last status code is CR, refers to as constructed record, which means the as built model. This model can be further used for asset management. Version and revision. The revision and version is to identify the latest updated information contained. There are two types of revision. One is preliminary revision represented by P, and second one is contractual revision represented by C. The contractual revision happens in published state if the submitted model or document or drawing are approved, whereas the preliminary revision happens in the work in progress, shared, and also in published state only if the model or drawings or documents are partially approved, which means approved with the comments. The preliminary revisions are represented by adding two integers after P, that is P01, and the version is represented by adding two integers after the preliminary revision P01.01. So for any information container, the initial state is P01.01. For any changes happening to the information container within the WIP state, it can be called as version. Similarly, if the information container is coming back to the WIP state from the shared or published state for any changes, it can be called as revision. When this information container comes back to WIP state like this, the version has to restart from 01. Now we will look into the workflow of the revision and version. As discussed earlier, the initial state of the information container in WIP state is P01.01. When there is a change after the review by task team lead or within the task team, it becomes P01.02. And for each change happening after the review by task team lead or within the task team, in the WIP state, the version keeps on increasing. Here we can see that the final information container state is P01.05, which is the final approved version by the task team, and it is transferred from WIP to shared state for the approval from the lead appointed party or appointing party. But they have given some comments for change. So the information container comes back to WIP state, but the revision is changed from P01 to P02. In the WIP stage, more changes are happening and the information container changes from P02.01 to P02.03. This information container with P02 sent for approval from WIP to shared after the internal review within the task team. That is also rejected and comes back from shared to the WIP state. Now the new state is P03. The internal review happens twice and the state changes from P03.00 to P03.02. So this is again sent for approval of the lead appointed or appointing party. So this information container with P03 is now in shared state. It is reviewed and accepted by the lead appointed or appointing party. Now this information container moves from shared state to the published state and this can be used for contractual purposes. So its revision code becomes C01. If this information container needs any change, it is sent back to WIP and goes through all the discussed process and revision code becomes C02 when it comes back to the published state. Now we are coming to the end of the session. We will conclude by looking into the benefits of the CDE. Single source of truth. We have already discussed the amount of information that is being generated related to a project. Making this available in a single source saves each and every stakeholder's time. This helps for better decision making and to generate insights using data analytics. Enhances collaboration. When the information related to a project is on a single platform, this binds the team members together, which improves the collaboration within the team and between the teams. Transparency. The initial process of uploading the information to a CDE is a manual process, but the rest of the process is automated as predefined. So the manual interruption is reduced to the minimum, which reduces the risk. All the relevant information related to the project is available to all the stakeholders of the project. Improves efficiency and quality. The manual intervention and miscommunication are two major issues in the AEC industry. As the major CDE processes of review and approval are automated, both these issues are resolved. It is not only one level of review that happens in a CDE. There are different levels of review that is happening, which improves the efficiency and quality of the project. Information security. The information in a CDE has controlled access. Only relevant stakeholders have access to the relevant information. The right to edit information generated by a task team is reserved to them. None of the others can edit it, but the same can be used by other task teams for any reference purposes. Identification of right information. Each of the information containers in a CDE is defined with a file name in a predefined format along with status code, revision, and version. This helps to identify the suitable information container for the right purpose. Well, it has been a long session on CDE, its benefits and implementation strategies. We hope this webinar has conveyed its core intention, that is, the absolute importance of deployment on a project. With that being said, a mere CDE technology platform will not solve your information management struggle. A framework in which this CDE has to be developed, implemented, and used by all stakeholders need to be defined during the initial setup of the project standards through the Exchange Information Requirements (EIR), accept and confirm through BIM execution plans by all relevant stakeholders. As a project owner, You need an information manager who can facilitate all these activities smoothly. We are confident that information management roles in the project will be playing a significant impact on the way construction projects will be managed. To support these needs, the SAPEX has been running these essential webinars on ISO 19650 framework, information management framework, and the corresponding areas for industry professionals, students, and most importantly, project owners to gain greater insight on how it can enhance their project delivery. If you are interested in diving deeper into information management, please watch the previous sessions from my colleagues related to information management, ISO 19650, etc. available in the YouTube. I would like to open the session for the audience to use the QA section and send in their questions related to the session. Deshapex is committed to support best practices in construction project delivery and will continue to bring more such sessions in the future. Thanks to all participants for tuning in. We will see you in the next webinar. Until then, if you have any questions or want to know more about best digital engineering practices in construction, please reach out to Deshapex via platforms below or set up an appointment to meet us in person at our office. Thank you.